Okay, so we are talking about the 11th problem, exercise 6.3, right? What is it, 6.3 or 2?
3, sir.
Yeah. Okay, so they have told you that ABC is an isosceles triangle. So that we need to keep it in mind. And of course, by looking at the figure, or even isosceles triangle ABC with AB equal to AC. So AB is equal to AC, that's given to you. AD is perpendicular to BC. And EF is perpendicular to AC. Prove that triangle ABD, where is ABD? This one, okay. ABD is similar to ECF. Okay, so what you people have done, those of you who solved this problem, which one did you leave?
Sir, first angle B is equal to angle C, sir. Because angles opposite to equal sides are equal.
Yes, this angle B is equal to this angle C, all right.
And then angle ADB is equal to angle EFC, which is 90 degree.
Yes, perfect.
So triangle ABD is similar to triangle ECF by AAA similarity.
Yes, we can call it as AA similarity. We have used only two angles, no? Third angle, we did not prove that it is equal, but anyway, it will be equal, of course. But if you write only two conditions, use the AA similarity, okay? There is no reason for going to AAA because two angles same means third angle is also obviously same. No need to write that anyway, okay? But you should know that both are same. Okay, so anyone wants me to write this? This is very straightforward. One of the angles is 90 degree and the other one, because of the isosceles triangle, this angle B will be equal to angle C. So B corresponds to C and D corresponds to F. So of course A and E will be equal. Confirm, guys, everyone understands this? Can I move on to 12th question?
Yes, sir.
All right, so side AB and BC of, okay, side AB and BC and median AD of a triangle ABC are respectively proportional to the side PQ and QR and median PM of triangle PQR. Show that triangle ABC is similar to PQR. Okay, who all have completed this sum?
I have completed.
Okay, let's do this one. So there are two triangles, ABC and PQR. That's what they asked, right? ABC and PQR are similar. So let's draw them as a similar triangle. Now AB, BC and AD. So we have to draw a median AD like this. And for the other triangle, what is that? PQ, QR and median PM. So we have to draw a median PM like this. Now, tell me, what is the condition that is given? What are they saying here?
AD by PQ is equal to BC by QR and that is equal to AD by P.
Yes, very good. So they have told you that these three sides, AB, BC and AD, that means AB, BC and AD of a triangle are respectively proportional to the sides PQ. Respectively means what? 1 by 1. So AB will be proportional to PQ. So let's write PQ below AB and QR below BC and PM below AD. So that is the condition given to you. So we know what? AB by PQ, BC by QR, AD by PM. This is what we know. So two of the sides, they are already in proportion. This is a very straightforward question. So what can we do? Tell me what you people have done. I can write it as AB by PQ is equal to BC can be written as 2 times of BD, correct?
Yes, sir.
And QR can be written as 2 times of QM. And leave this AD and PM as it is. Cancel the 2 and 2. So what do we have finally? Give the reason also. Why are we saying? Since AD and PM are medians. So they are medians. That's why D will be the midpoint. That's why BD will be half of BC and QM will be half of QR. All right. So how can we write it? Now I can write it as AB by PQ is equal to BD by QM is equal to AD by PM. Now, what does this condition tell us? By SSS similarity, what will happen? Triangle ABD will be similar to triangle PQM. Is that right or not? And by CPST, what we can say?
Angle B will be equal to angle Q.
Yes. So now we already had two sides in ratio, and just now we proved that the angle between them, this angle and this angle, they are equal. So we can use the SAS condition and we can prove that ABC will be similar to PQR. Okay, so let's write it down. So in triangles ABC and PQR, what do we know? AB by PQ is equal to BC by QR and angle B is equal to Q. So by SAS similarity, triangle ABC will be similar to okay. Everyone okay with this? Confirm. What did we do? Very simple idea. BC by QR was given that they are already in ratio of the other two sides. So we split it up as 2 times of BD and 2 times of QM. So 2 got cancelled and we got this ratio BD by QM. What did that do? We got this side and this side in ratio, and the third side was already given that it is in ratio. So in these two triangles ABD and PQM, we were able to show that by SSS similarity, these two triangles became similar. Why did we go through all that trouble to prove that they are similar? Because we wanted one of the angles to be equal, this angle B to be equal to Q. So if B is equal to Q, we already know that two sides are in proportion, and the angle between them that is equal means it will become SAS criteria, and triangle ABC will become similar to PQR. Okay. So moving on, 13th one. D is a point on the side BC of a triangle ABC such that ADC is equal to BAC. ADC is equal to BAC. Now they're asking you to show that CA square is equal to CB into CD. Anyone has done this? 13th one? Okay, so we have a triangle ABC. Let's draw that triangle first of all. Okay, D is a point on the side BC of a triangle ABC in such a way that angle ADC and BAC will be equal. D is a point on BC. So let's say D is some point over here. And if we join this, remember this is not a median. This is just some point on the line BC. Now, what are they saying? Angle ADC and BAC. ADC, BAC. Let me write it first of all. Okay, now let's try to visualize which is that ADC. Okay. Now I did not draw it properly. So let me draw it once again. Since we are saying that ADC is equal to BAC, BAC is an acute angle, no? So I would draw that D in such a way that it is an acute angle, okay? So let me draw it over here. So this angle and this angle, they are same. BAC and ADC. So this should be straightforward. Can you tell me by giving this information, which triangles can we prove that they are
Triangle ABC and triangle ACD, sir.
yes. Okay, we can prove that, but let's see what is it they're asking us to show. They're asking to show that CA square is equal to this. Okay, so what we understand from here, CA square means what? CA into CA is equal to CB into CD. We have done problems like this, right? Where two sides were multiplied like this and we rearranged it to get the ratio. So how should we do that? Let's see. As you can see, right? If you look at the figure, the triangle just now we figured out that we will be able to prove that this triangle yellow one will be similar to the big triangle ABC, correct? Which similarity rule can we use here?
AA similarity, sir.
Yes, we can use AA similarity because one of the angles they have already given, which I have put it in red, and another angle will be common. This angle C will be common in the triangle ADC and triangle ABC. So let's write it down first of all. In triangle ADC and ABC. So it is already given that triangle ADC is equal to BAC. This is given. Now, what should I call the angles? So understand that in these two triangles, D is going to be corresponding to the A for the bigger triangle. The D in smaller triangle corresponds to A in the bigger one. And of course, C will correspond to C only because that angle is common. So what is the other thing? A will be corresponding to B. So just write it down. What will be the angle C over here? In the smaller triangle, angle C will be DC A, and in the other one, it will be AC B. Common. So by AA similarity rule, what will happen? Triangle ADC will be similar to triangle. No, I didn't write it correctly. Did I write it correctly? ADC and so A corresponds to D in this one. So it should be ADC will be D.
Sir, angle A is also common. No?
Angle A is common? No, we are talking about this small triangle. So in the small triangle, this angle is smaller, right? Full angle over here versus this small angle over here. Angle A is not common. Only angle C is common in both of them. Try to visualize which triangles we are talking about. We are talking about the big triangle versus this small triangle. So they have already given that A is corresponding to D and C is corresponding to C. Yeah, tell me, what will be the similarity condition over here? Triangle. If I'm writing it as ADC, it will be similar to, what did I say? Triangle. Let me leave spot for the first one. I don't know what A will be corresponding to. I know that angle D corresponds to angle A, right? That was given. So in place of D, let me write it as A. And in place of C, I will write C only because that was common. So AC, and then of course the other one will be B. So it will be triangle BAC in the proper order. Did you people understand why I went through all that trouble to write down the proper order? Because we need to write the vertices in proper order. A corresponds to B, D corresponds to A, and C corresponds to C. This is the smaller triangle. This is the bigger triangle. Confirm, guys? Do you understand?
Yes, sir.
Yes, sir.
Yes, sir.
All right. So, yeah. So now we know the similarity. Now, how would I get this CB into CD and then CA into CA? How would I get that?
Sir, can we write angle ACD will be equal to angle ABC by CPCT so that like those two angles will be equal, and if we using isomorph property, we can write AB is equal to AC.
No, we don't have to. We just have to use the CPST of this triangle and you will be directly able to reach this stage. No need to prove anything else now. Okay, you see, I need CA and I need CB and CD. Where would I get my CD? CD is of course over here, right? So let me write CD from this triangle. If I'm writing CD, what will be the other corresponding in the other one? It will be CA, right? So CD by CA is equal to I need CB also. So CB from this, but this triangle has to be written in the denominator, right? So this CB will come in the denominator and that will correspond to CA in this triangle. Okay, now try to understand this. This CA corresponds to this triangle, bigger one, but this CA corresponds to this triangle, smaller one. That is why this is one of them is in denominator, other one is in numerator. But when we cross multiply, they will multiply together and they'll become CA square. And as you can see, CB and CD will also multiply and we'll get the required result. So you have to look at what you need to prove, and based on that, you will write the particular condition. Tell me, will you be able to write it? CA from here, no, CD. We have taken CD from here, and that is equal to CA from this triangle. CD, CA. Similarly, we take CA from here, and that becomes equal to CB from this triangle. Are you people able to understand how I wrote this relation? Are you people able to get that? Confirm? If you're not getting it, tell me. Okay. I got confirmation from one person. What about the rest of you? If you're not getting it, tell me. Speak up, guys. I don't speak that silent language. I don't know whether you understood or not.
Understood, sir.
Yes, sir.
Yes, sir.
Okay. So this is just the similarity CPST we have used. Okay. So just write it as by CPST. Then we can rearrange, write it like CD into CB is equal to CA into CA. So which we can write it as CA square is equal to CB into CD. This is what they wanted us to write like. All right. One. You said in your school, ma'am went to 16th question directly, right? So did you see that 12th and 16th question is similar or is it different? Have you already solved 16th problem in class, Ryan people?
Yes, sir.
So was it similar or it's different?
We started it, sir. Didn't complete it.
Okay. So actually this problem looks similar, but there is a difference between how you solve them. Okay. It's not straightforward. The 16th problem, I think, from what I remember, it solves in a different way. Okay. We'll get to that. Let's go in order first. 14th problem. Let's try to finish this 14th problem today at least. So what does it say? Side AB, AC and median AD of a triangle ABC are respectively proportional to side PQ, PR and median PM of another triangle PQR. So ABC and PQR, you have to show that they are similar. Okay. Yeah, this problem seems similar to some problem which we just solved, but let's see how it is different. AB, AC, and median AD. Remember, this time they have not given us the side BC. They said AB, AC, and the median. PM, is it PM only? Yeah. Think about it, guys. Can you prove it using the similar idea which we did sometime? Just which question did we do like this? Yeah, 12th question. Yeah, 12th question. It looks similar to the 14th one, not the 16th one. That's why I got confused about that. The number. Read the 12th question again and read this 14th question again. I want everyone to read these two questions. Tell me what is the difference here? What is the difference between 12th and 14th question? So you can look at this figure over here, okay? Even though these two questions are not related to this figure, but this figure is same for these problems, okay? Figure will be exactly same. I want any one of you to tell me what is the difference here.
Sir, in the 12th question, they gave the bases are corresponding. And in 14th question, they gave the other side, AC and PR there.
Yes, absolutely right. Very good. But tell me how, if this is the case, can we use the similar method like what we did earlier? What kind of problem it is creating for us? They have not given us BC and BC by QR is equal to the ratio. So is that creating a problem for us, or this is a similar problem we can just solve like that? I want you people to try it for a bit, okay? Draw the
We
figure.
won't be able to take that half of BC is equal to half of QR and then prove like that, sir.
Yes, it's not very easy to prove that triangle ABD is similar to PQM. It's not so simple, just like doing half of BC and half of QR like that. Now, if we can't do like that, then what we can? How can we prove based on the given information? How can we prove that the triangle ABC and PQR is similar? Try to think about it for some time. Anyone has any idea? what we can do here? Okay. So what I will do, I will give you a hint. You try to solve this in home. Okay. This is slightly lengthy problem. What you have to do is, we can't directly prove that any of the sides or angles is equal in this. So one of the ways would be to extend this side AD in such a way, let's say we extend it to this point E over here. Okay, AD and DE should be equal, extend it like that. And then join these two lines. Do the same thing here also, extend PM also to N, let's say, and join this. Okay. So now what I want you to do is, I want you to apply some logic and prove that the ultimate last final goal will be to prove that this whole angle A is equal to angle P. Okay, but we won't be able to do it in one go. So what we will do, we will take it in half. So let's take this part first. Angle CAD is equal to angle RPM. So this is what we want to prove in the first stage. How can you do that? I will give you a hint for that also. You pick these two triangles. Okay, you pick this triangle ABD and DEC. These two triangles are congruent actually. This triangle and this triangle, they are congruent, not similar. Remember, I'm talking about congruence here, not similarity. So these two triangles are congruent. So try to think why they will be congruent, what congruence rule will apply here. So those things you will try to think. And exactly same way, this triangle here will be congruent to this triangle. So these two triangles are congruent. Find out how, and then use that condition to prove that let me write it down for you. Show that triangle ABD is congruent to triangle ECD. Also, triangle PQM congruent to NRM. And once you are done with these two, then you should somehow figure a way to prove that triangle ACE is similar to triangle PRN. Because once we are able to do this, then by CPST, what will happen? This angle over here will become equal to this angle. So these two things you have to try it in home. And this one everyone has to try. Don't give me, I don't need any excuses from anyone. Everyone has to try this. All right. So let's stop here.